Okay, let's look at number 2. What is the converse of the following conditional? If a point is in the first quadrant, then its coordinates are positive. So remember, the converse is like the reverse of your original if-then statement. Our ifs become our thens, and our thens become our ifs. So we would say if the coordinates of a point, we need to keep our subject. If the coordinates of a point are positive, then the point is in the first quadrant. Okay, that is the converse of your original statement. Number 3, write the 2 conditional statements that make up the following biconditional. I drink juice if and only if it is breakfast time. I drink juice if and only if it's breakfast time. So we have 2 statements that we can write in if-then form. If I drink juice, then it is breakfast time. Okay, and remember the biconditional, the original and the converse are true. So then the converse of that would be if it's breakfast time, then I drink juice. Okay, so we would just take one statement and write the converse of it. And those would be the 2 separated statements that make up the biconditional. When a conditional and its converse are true, you can combine them both as true, and that would be, again, biconditional. When a conditional statement and its converse are true, they can be written together as a biconditional using the phrase if and only if. Number 5, it's given that the measure of angle PQR is equal to x minus 5, and the measure of angle SQR is equal to x minus 11, and the measure of angle PQS is equal to 100. And we're to find x, and we're to justify each step in finding x. So we'll start with the fact that if we have angle PQS, it's equal to the sum of the measure of angles PQR and SQR. Okay, that's the angle addition postulate that says that if 2 angles have a common vertex inside, we can, add those measures of those angles together. And then, they're going to continue to solve. They're going to substitute, the measure of angle PQR with x minus 5, the measure of angle SQR with x minus 11, and so forth. And then they're simplifying by combining like terms. You have a minus 5 and a minus 11. That's minus 16. And then they're going to add 16 on both sides. They're trying to get x by itself. So remember, we get rid of addition and subtraction first. So we're going to add 16 on both sides. That's the addition property of equality that says if you add the same value on both sides of the equal sign, then your equality statement remains true. So that's going to be the addition property of equality. All right, I think we'll stop there.